QGIS applications yesterday. Yesterday, we mainly focused on how data is acquired and how this data is inputting into the QGIS platform, and how we can create new data like we did it in some points and polygons we did it yesterday. So that is data creation. And finally, how we are going to taking outputs. We made a PDF format of a map. So basically, how it is taking out is an output. These were the main objectives of yesterday's class. Uh, in addition to the these three things, we can do many analysis into uh, in a QGIS platform. So today we are mainly focusing upon the QGIS analysis part, which is a bit complicated, uh, and the hands-on part is not that easy, and we cannot do it in a 1 hour session. So I just want to explain what can we do, uh, what all processes can we do in this analysis platform. So here in the slide, you can see the GIS process. Any GIS process or geographic information system processes start with the real world. We need to have a real problem or a real scenario which is happening in the Earth's surface. So all GIS processes will start from the real world. From there, we are understanding or trying to understand a real world problem or a scenario. Based on that, we need to collect data. Yesterday, we collected data from the government GIS platform. Uh, you can collect data in many ways, like you can collect it from government platforms or other maps, or even you can go to the site and collect some data. Uh, or you can create data based on some previous databases. So all this way we can collect the data. Then you have to input this data into the GIS platform. Yesterday we have done data management, but in a very small scale. You can do it in a very large scale. You can do it in a uh, world scenario, or a nationwide scenario, or a statewide scenario. Uh, the processes are the same, but the data handling capacity of GIS is very huge. So basically, you can manage the data, you can store it, you can process it, and you can query something into that. So all this comes into data management. Some from this data we have collected, you can do some analysis on it based on different data sets, and you can arrive. Data is just not the information. You need to process it and get the information, and from the information it can transfer into the knowledge, or you can use that information for the better decision making. Then with the informed decisions, you can implement uh, again into the real world issue that we started with. So any GIS process starts with the real world problem and ends with a solution to that problem. So this is basically the process involved in uh, GIS. Uh, but in the class, we are now discussing more about analysis. So what is spatial analysis? We can do 6 things in GIS. One is capture, one is store, both are data. Then you can do query, what is happening there, it's just a query. Then you can analyze, then you can display it, and you can get the output. So query and analysis, which is the part which converts this data into information. So what is really happening in, I'm just making a flowchart here. What is happening? Here it is the real world. It's just a representation. Still, it conveys the idea that it's chaotic. We cannot understand the real world just looking into it. So we have to uh, separate all data layers. Like we have buildings, we have water bodies, we have separate uh, what you say, you have land uses, then you have so many networks like roads, railways, then water channels, all these things. Then you have vegetation, then you have terrain, the elevations. All this contribute to different layers of data, and overlaying all this, you will get a real world situation. But for analyzing, for the easiness of analyzing, we need to separate all these data layers into separate sections. So I'm explaining again. Yesterday we have seen how we can identify a site for our residents. Similar in a similar way here, the question here is locate a new school. Where can we locate a new school? So for understanding which is the best place for a school, there are so many data layers we need to input, like land use, which is the best land use for uh, to selecting a site for the school. Then you need to find out the elevation, then recreation sites, existing schools, all these things we need to understand. But simply understanding these things will not convert into a location. So we have to analyze. This process is a simple analysis. For example, here it is elevation. Elevation is just some numbers, so we cannot take anything out of it. Then you can convert into slope. This process can be done in GIS platform. The elevation model, GIS will convert that into slope. What is slope? Slope is like what is the steepness, or where are the areas which have high steep terrain, or where are the areas which has flat terrain. So from there you can simply getting the slope also will not give any useful information, but you have to categorize it. Uh, in our decision to put a school in a particular region, we can decide that if the slope is more than 20%, 20 percentage, then school cannot be placed in that location. So you can categorize that slope analysis model, and you can see that the green areas are possible locations for a school. So these two arrows, this analysis we can do it in GIS. Then from there you have so many points which leads to this location decision. So you have to transform all these layers into a single one. So we are going to wait and combine all these things, and you are understanding that okay, these green spaces are good for a school. And finally you are locating a location where you can the most probable area for a school. So these arrow marks represents the GIS analysis tools. uh, Through that process we can get the position for a school. A little bit of history. It all started, the spatial analysis, it all started in 1854 by Dr. John Snow. when there was an outbreak of cholera in London. He actually what he did is he mapped all the cholera death cases in a particular region, and he also mapped all the water resources point in that particular region. So this is that map. All black dots are for cholera deaths, and all this into marking is for the pumps or the water sources. From the just putting these two data sets into a single map, he could understand that this uh, cross mark or this pump is the main source of cholera cases, or some nearby wells also. There are some spatial relationship between the cholera cases and this well or pumps. So just by treating this water in these wells, simply they could control the cholera in that particular situation. So all this data, this is the most simple case for this spatial analysis, but the effect is huge, so that they could control the cholera. Before going to analysis, I just want to say something about querying. Query is a system which is there in QGIS or in any other GIS platform. Basically, in analysis, what is the difference between analysis and query? In query, we will not make any new layers or new data sets. It's just we are asking something to the system, and it will answer uh, it. Basically, we do it in Excel or something like that. Same in similar way, we can say we can do basic Boolean operations there. So here the tab for querying, you can say what is equal to operations, or less than or in between cases, or more than cases, or like, and, or, not, null. All these things can be done in query. For example, if you have 100 schools in a district in which 56 schools are getting government aid. So we are asking how many schools are there which does not have government aid. So if you have the list of schools, and you have the data which are having this government aid, you have to count one by one to get the data, that is which are the schools which doesn't have this aid. So by clicking simply a simple click, you can get which are the schools names which doesn't have this aid. So it's a simple function, but you can extract many information from this. But the basic difference between analysis and query is that you are not creating a new data set. It's already there. It's JS is simply putting it together and showing you some answers. That's the query part of it. Then we are going to analysis. In analysis, as I said, uh, taking the previous case, we can see that all these processes create new data layers. If you are going to locate a school, you have to first get the base criteria. These are the acquired data sets. But afterwards, you have elevation, then you have to create a new geographic data based on the slope. Then you have to transform into some other layers, and then you have to add all these layers and create a new layer. Then you have to locate a position for the school. All this will give you a new data or new geographical data set. So basically, what is the process? Every data analysis or every GIS analysis starts from a question. you have to break it down, and you have to understand who is the uh, audience, or what is the purpose of asking this question. Then you have to explore the data. What are the data we require for analyzing, and what are the correct representation of that data. We can acquire many data, or you can create data, but you have to understand, is it the correct representation model for your basic data. Again, you have to know the distribution. If you are particularly looking into a location, your data should have the information for that particular uh, area, or accuracy. Data may vary in its accuracy point, so you have to get most accurate data for a particular problem. Scale and format are also important. So based on this, you have to select the base criteria data. That is the second layer here. All these things, land use, elevation, recreational site, and schools, all the acquired data. You have to explore this, and you have to find out what is the way forward. Then you have to choose the method. This is the most important part of this analysis. What analysis should we do information? So basically in QGIS, you have hundreds and hundreds of analysis, in which is the most suitable one for your case. This is, you have to decide upon various factors, of course, like review questions, common approaches, what are the most best practices around is it data suitable, it is the data uh, uh, compatible, all these things you have to check, and you have to select the process in that. Then the perform analysis, it can be done in many ways, like JS can do basic models, and you can uh, combine the analysis tools and get more complex analysis. Then you have to get the results, and while getting the results, you have to again check, is it the real way of this is the real answer to your initial question. Then you have to convert that into a visual output, or a useful output. Then the analysis part is over. As per ESRI, that is the developer of ArcGIS, there are 6 categories of spatial analysis. One is understanding where, then second one is measuring size, shape, and distribution, determining how places are related, then finding the best locations and paths, and detecting and quantifying patterns, then making predictions. We will see one by one. First question, very simple one. Where are the coffee shops and delivery trucks are? This one we always use in our mobile phones, in our maps, Google Maps, all these things. Where are the restaurants near my location? All these things are coming in this work, under this work question. Then you can again ask, where are the greatest concentrations of crime in a city? Similar questions can be asked to the GS. Then it will map, and it will uh, create a density map. Here you can see the density map where the points are located more closer. It is showing in a red color. So it shows the density maps, from where we will get an idea that there is some problem, or there is some issue in that particular location. What we can ask further questions, and we can ask further analysis on this, like why it is concentrated on this particular area. Then you will go to another analysis, or you can go to the site and you can check what is happening there. So understanding where will give you some other insights, and you can go further into that issue. The next complex system, that is the second one, is measuring size, shape, and distribution. Example, how large are the cocoa fields? How long is the river? How tall is the building? You can ask queries, or you can ask, you can do a real analysis on all these things, on all these criteria. And the second one is, what is the center of disease outbreak? As we see in the first example, that is the cholera case example, why it is happening like that, what is the relationship between one thing and the other thing. So we will get a simple idea like that. And the third one is, what is the slope aspect and curvature of a drainage basin? This is much more complex than the previous two cases. Here the surface functions to describe the properties of continuous surfaces. So it basically comes under raster analysis. The previous ones were vector analysis. Then the third complex thing, that is determining how places are related. Here, two geographic conditions are uh, analyzed by just placing one over another. The first one is, which rivers are within 10 miles of a pipeline. In this case, pipeline data is one layer, and river data is the second one. So we are analyzing both of them, uh, laying over one over other. So we will get a information from that. This many areas are covered under uh, a particular river, which is related to the pipeline. And the complexity increases, like what is the percentage of each parcel that is in a floodplain. So like this, the two layers are, one is floodplain layer and parcel layer, property parcel layer. So we can understand the situation of a flood, and we can take mitigation measures for in case of a flood for these parcels. So this will go on, and the complexity increases. Then what locations are within 4-minute drive time of hazardous materials response unit? So we have hazardous materials response unit in one layer, and other in the other layer we have 4-minute drive, 4-minute drive cases, or 4-minute drive locations around that particular point. So we will get, is there any points which are not accessible from this central location or something like that. Then what are the three closest post offices along a road network? Here it comes the network analysis, where you can identify the closest post office in your location. Another thing which we already discussed in the previous case of school, finding the best location and paths. Here, where is the best location to create a new wildlife conservation area, similar to the best location for a residence or best location for a school. Another thing is, what is the best way to get from point A to point B? How will water flow through a water or sewer network? This will usually do it in again in Google Maps. We will find out the best routes for reaching a particular location. So it's similar. We all use these things in our daily life. The fifth one is detecting and quantifying patterns. We have many data layers in this, and we have to find out why why some areas or some properties are sold in higher prices. So we will locate that in that data layers. Then other thing is, what are the areas with similar vulnerability characteristics based on socioeconomic status, governance, population density, and climate change. So we are weighing it based on this socioeconomic status, governance, population density, and climate change. The cases are very generic. You can do similar analysis in GIS. The sixth most complex analysis is modeling or making predictions. What happens if the situations happen in so many ways. So here, the first example is, how will buildings cast shadow or reflect sunlight? You can build a model and for a new building or a proposed building, and you can check where are the shadow patterns, or how sunlight is reflected from that particular facade. All these things can be done in GIS. Then next, we have a successful store location. Can I take a 1 minute break between?
Hello, ma'am. I think we can continue, ma'am. We'll finish it off. Hello, ma'am.
No, I have an issue here.
Oh,
I have an issue
okay,
issue
ma'am.
here.
We'll
One
take
second,
a
1 second.
we'll take 5 minutes break. No problem, ma'am.
No, I need just 1 minute. Okay.
Okay, ma'am. Okay, okay.
Okay, I'm back. So in this case, we have some successful store location. So we need to propose a new potential location for uh, a new store, which will rank similar to this successful store, where you can rank based on uh, various factors. And here they have identified some locations based on rank. This is the most suitable location after the successful store. Then three, then here is one, there is four, and there is five. You can uh, select one of this to uh, have the new location. Then we have another issue: how will illegal drug use grow and spread? We can predict, like based on some conditions, we can predict what will be the uh, spread of drug dealing. Or another case, how will a forest fire spread based on vegetation and wind at a particular situation. Or we can see that how will uh, a disease spread. We did it in our COVID-19 spread time. The same case, how will disease spread based on social interaction? Mm, Based on the contacts patient had, you can predict where will the most suitable area or most cases will happen in the next few weeks or few days. How fast will a pollutant disperse in an ocean? Yesterday, I have discussed this. When there is a oil spill, where is the most affected areas, or which are the species of fish or ocean life which will get affected the most. All these are modeling, or we are predicting some trends. Okay, this is the sixth most and the most complex analysis we do in GIS. Even though there are different complexity levels for the analysis, all these things will uh, can happen with the combination of this, like union, intersect, identify, clip, dissolve, merge, buffer, and split tools which are available in GIS. So in a union, what we do is inputting two or more data layers, and we combine them and make a new layer which is combined these two layers. So we are creating a new data set. Or we are intersecting. We have two layers in which two or more layers in which are the parts intersecting each other. Or you can identify, like inputting two or more layers and identifying the aspects which are uh, there in both layers. Or you can clip it, like here there are in the first layer you have some data, and in the second layer you are making, again it is similar to the intersect, but you are creating a new layer which flips one layer from the other. Then you can even dissolve that. We have similar data for more than one uh, geographic areas, so we can combine these areas in based on its similarity. So data we are reducing it, then merging. If you have two data set for two different locations, or we can combine them or merge them. And we can buffer, if you have a river, and buffering that river for some protection, we can do a 5-meter buffer or 10-meter buffer. All these things can be happen in GIS. Then you can split, like we merge, you can do the opposite of that, you can split. All this analysis we can do it in GIS. So basically, these are the things we can do as analysis. Just I'm one more part. Just I'm showing where we can find all these analysis tools. In this is yesterday's files. Here you can see there is a processing toolbox in QGIS. If you don't have that in your desktop, you can go to this toolbar panel, right clicking this toolbar part, and you can open it from processing toolbox panel. You can see many analysis tools. Each of this section will have many more. So these are all the tools which can be used for the analysis. For the simple analysis, we have this over here. There are two types, vector and raster analysis. Vector analysis, you can get it from here. Some basic things, the basic buffer, clip, all the dissolve, union, all these things will be here in geoprocessing tools. And raster analysis, all these things are here. Okay, so that is it. Then so these are the inbuilt tools we have in our QGIS system, but you can also add plugins. The QGIS is a free software, and anybody can make a tool for analysis or doing something else, and you can give that to QGIS platform. So there are so many plugins available to us. So in plugin section, if you go to plugin section, you can manage and install new plugins here. So you will get a long list of plugins. You can open that and install that plugin for your use. So all these are free plugins available in the platform. Depending on your requirement, you can go there and download the plugin. So the basic thing before going to an analysis part is you have to ask the good questions, or if your questions are correct, your answers will be good or will be useful. And the second thing is, when you acquire data, it should be accurate, and the accurate data will give you the good information. So if you want to further go into analysis, you can go to QGIS website. There is a whole lot of videos available there, whole lot of documentation available there, how we will do the analysis. So attempt all those things. It's very interesting to do analysis. Uh, okay, so hope all you do some analysis in the future. Thank you. That's from me. Thank you.
Okay, thank you, ma'am. Thank you for your valuable and informative session on QGIS from its basics to its application level, including the hands-on session during this short time interval. Thank you, ma'am. Thank you very much.
Thank you.
Now, participants have, if you have any clarifications regarding the QGIS that we have, sessions that we have covered today or yesterday, you can have a discussion with the ma'am right now. Any clarification from any participants, you can have it right now. Okay. I think participants are not responding. So I think it will be okay for them, ma'am.
Okay, sir. We will mind that.
Anyway, so all of you know that today is the last day of our FDP program, and also today afternoon we don't have any session. We all know that all the softwares we covered are very vast, and it is not possible to cover in detail in this 1 week time. Anyway, I thank all the participants from various colleges for joining this program, and hope they will be benefited to a certain extent regarding the basics of all those softwares that we covered in this hands-on training program. Now it is a time for feedback session. If any participants have any feedback related to this program, you may have it right now. We'll open for 5 minutes. Any feedback, if any participants, you can have it right now. We'll consider your feedbacks and requests, and we'll try to improve in the upcoming sessions. We have planned this FDP in a very short period of time.